Remember, when you are given any question involving triangle, you can use if it's a right angle triangle, you can make use of the Pythagoras rule. If it's a right angle triangle, you can use Pythagoras rule. You can use this other rule, SOHCAHTOA. I know many of us have heard of this. This is sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So if you are given a right angle triangle, you can use Pythagoras rule. Pythagoras rule is only used when only the sides are given and when it is a right angle triangle. And this one is used when the angles, any of this, one of these angles is given, so you can find the other side. But what if it is not a right angle triangle like this? What if it is another type of triangle which is not right angle? So you make use of the cosine rule. A square equals to b square plus c square minus 2bc cos a. This is the cosine rule. So this letters here represent the sides, and A here represent the included angle. So this is angle A, this is angle B, this is angle C. And when you label a triangle, you should know that the angle is opposite. And the side here is opposite to this angle, and the side here is opposite to this angle. So we can label this as side A, we label this one as side B, and we can label this one as side C. Now let's assume that this triangle has a height h. So if we divide this triangle into two, but not two equal parts, we divide it into two, and then one side is bigger than one side. Remember, we form a right angle triangle, two right angle triangle. So we can label this as the height of the triangle h. And then now if you consider this side to be x, so this other side will be what? Remember, everything here is b, and this other side will be what? B minus x. So if from this point, if here is x, this will be what? B minus x, because b represents the other side. This side is opposite to this other angle. Now, how can we prove this rule? We can use the Pythagoras rule to prove the cosine rule. And this is how we start. We consider the first triangle. The first right angle triangle here is triangle BDC. So we are going to label this one as D because we've cut the triangle into two. So we label this as BDC. So now let's prove it. From triangle BDC, we can see that if you want to apply Pythagoras rule here, you see that a square equals to what? Remember, Pythagoras rule says that the square of the longest side of the triangle is equal to the sum of the squares of the other two sides. So this triangle BDC, this is the other two sides, h and b minus x. So I'll say b minus x all square plus h square. So this is, you can expand this. We have a square equals to b square minus 2bx plus x square plus h square. This is your first equation. Now, you've had your first equation. And if you check that this looks similar, kind of similar to this, except that there is no c and cos a. So we are going to look at this other triangle here because we have c, side c, this other side. So we are going to say from triangle B, D, or let's say ABA, B, D, you can see that if you want to find the side, this longest side, you use Pythagoras rule. You say c square equals to h square minus, or h square plus x square. You have this. From here, you can make h the subject of the formula so that you can find what h is actually for. So if you make h the subject of the formula, you are going to have h square equals to c square minus x square. That is because I want to eliminate h square from here, because we don't have h in this cosine rule. In the rule here, we don't have h. So since you know that h is c square minus x square, you are going to substitute into equation 1. So by substituting h equals to c square into equation 1, and equation 1 says a square equals to b square minus 2bx. Now plus x square. When you have h, you are going to put plus c square minus x square. Now, you see, we have eliminated the height, the square of the height. We have eliminated h to represent this. So now, you know, in this equation, you can see that x square minus x square is 0. So you can cancel this out. And then we are left a square equals to b square plus c square. minus 2bx. And in this equation, we don't have x, so we're going to find the value of x. So what is, you can see we have c cos a. Now let's look at this. This is cos a, this is the side. This is the angle A. So we will check cos a equals to what? What is a? A is what? This is secant. Cos a will be what? Adjacent. The adjacent here is what? Is x over what? Hypotenuse, which is c. So if you cross multiply, you have that c equals to what? Oh, sorry, x equals to what? C cos a. If you cross multiply, x equals to c cos a. So you know the value of what? X. So you now substitute into this equation. So you now have that a square equals to b square plus c square minus 2b c cos a. So we have now proved the cosine rule. So thank you. This is a proof of the cosine rule. You can use this to solve any triangle that is not a right angle triangle, that the maybe two sides are given and the angle, then you are asked to calculate the other side. That is when you can use this formula. Or maybe when the three sides are given and you are asked to find the included angle. That is when you can apply the cosine rule. So in our next episode, we are going to have a proof of the sine rule, and then we are going to apply the sine and the cosine rule in solving many life problems. Thank you.